CBM is a new maintenance strategy being implemented in Europe as it has advantages compared to traditional approaches. Typically, locomotives are inspected in workshops at fixed intervals, which depend on the manufacturer instructions. These intervals don't take into consideration the locomotive's components' actual health and state, which can lead to either unnecessary replacement of components or a disruption of operation when a component fails unexpectedly. Condition-based maintenance, on the other hand, means that measures are only carried out when they become necessary. Locomotives are equipped with onboard telematics and continuously monitored. This data is merged with historical maintenance data and allows to predict component failures and schedule only necessary measures. Monitoring a specific component and developing CBM measures is called use case, and within the freight rail projects, more than 40 use cases have been developed. The backbone for CBM is the developed IT architecture. Starting point is the locomotive's onboard telematics, which is connected to the data lake via a mobile connection. There, all telematic data is stored and validated, and data from other sources could be integrated. Eventually, everything is transmitted to the analytics platform. In this platform, data is merged with sources such as the operator's ERP system, and this is where the sense-making of the data takes place. Results of the data analytics are, for example, user-friendly dashboards. To improve CBM actions, the feedback loop allows to gather additional information from workshops. The automation of processes goes even one step further. The digitalization and modularization of maintenance rulebooks facilitates the daily workshop processes, and data from the feedback loop and dashboard information can be linked to the superior ERP system. Dashboards are a user-friendly implementation of CBM use cases. To ensure user acceptance, design thinking methods have been used to develop use cases and dashboards following an agile and iterative approach. Starting point is the fleet management as users of the dashboards with its know-how, experiences, and needs. They know best how a use case can help to improve maintenance issues. The development process follows a hybrid approach where the empirical input from fleet management and other technical experts is combined with analytical input through a data-driven approach from data scientists who have experiences in pattern detection or algorithm training. Deployed results of this development can be either dashboards or more advanced and improved CBM methods such as email notifications or ERP ticketing. For these improvements, the developed CBM methods need to be monitored and validated. This way, the circle closes and validation insights can be used to further develop the CBM methods. In this video, we will show you different dashboards that give a comprehensible overview of the whole fleet, a single loco, or specific components. The landing page of the dashboards is this homepage that states the series of locomotive and gives access to the fleet and the loco overview. The fleet overview allows the user to keep track of the fleet status with a pie chart. Above the legend, users find the top-level navigation section, and below the pie chart, a component-based overview of the locomotive fleet. The pie chart represents the current status of the fleet based on the latest data available. The 6 defined conditions are based on their criticality, reaching from loco off, no data, to alarm. Hovering over the chart displays the exact percentage of locomotives in a condition. Decisive for this displayed condition of the locomotives is the condition of the worst component. In this case, 7.29% of all locomotives have a component with a warning, and all other components on these particular locomotives are less critical. Clicking on a pie shows even more information on the affected locomotives and components. Below the pie chart, you'll find an aggregated overview of all monitored components in the fleet. Hovering over a selected status shows how many locomotives have a component in this condition. The filter options above the table allow the user to select a certain time frame to be depicted or only certain conditions. The loco overview shows the condition history of all use cases in the locomotives. It is visible which components were and which ones are in a critical condition. This dashboard makes the impact of maintenance actions visible, like in this case where the pantograph of loco 12 switches from alarm to OK. Once again, hovering over a data point shows more details and improves the readability and usability of the dashboard. The same applies to the filter options above the table known from the fleet overview. Now let's have a look at specific components and their condition visualization in their dashboards. This dashboard shows the condition of the onboard battery system of a locomotive. The most important information, the actual overall condition of the component, is shown on the top left. The color-coded square indicates the condition of the battery, which is explained in written words as well. It states the date of this information and provides information on the last change in the company's ERP system SAP. At the moment of recording, the battery and charger functions are faultless, and the battery has been changed for the last time in January of 2017. This overall condition is derived from more than 90 KPIs defined by locomotive experts and displayed in the dashboard as well. The graph on the top right shows the battery's median voltage for the last 15 months, calculated over different time spans. You can select one of the 4 different voltage calculations and the graphs will adapt accordingly. The graph below shows the quality value of the battery during operation, which is displayed for short, middle and long-term time spans. The graph to the left shows the distribution of voltage ranges broken down by time span, and the table above even more calculated KPIs of the battery. As mentioned, all these KPIs combined lead to the overall condition of the battery, which can be displayed for any date and all locomotives in the fleet. This dashboard shows the condition of all diesel particle filters of the locomotives, which is determined by the 30-day median of the pressure. This KPI is calculated daily and displayed for each locomotive as a bar in the chart on the left. The condition is color-coded according to the displayed thresholds for warning and alarm. These threshold values were defined by the locomotive experts. Red stands for alarm, yellow for warning, and green for OK. By clicking on a bar, a more detailed chart opens on the right. It shows the maximum pressure of a day in green and the calculated 30-day median pressure in red for the last 3 months. This chart allows to understand the evolution of the values and to identify trends in the data. To conclude, condition-based maintenance helps increase the availability of assets. Maintenance costs can be reduced and material can be saved as unnecessary maintenance stops are avoided. Additionally, CBM helps speed up maintenance work as necessary components can be ordered in advance. Dashboards foster the CBM approach because they are easy to use for the fleet management. The developed backend allows for flexible customization of dashboards for specific use cases. Part of the backend is the underlying data structure. This structure can be adapted and implemented in other fleets as well and can help promote condition-based maintenance all over Europe.